Great. Good afternoon, good morning, good evening, everybody. Welcome to those that have joined online. So my name is Matt Sando. I've been working in financial risk management for the last 25 years, a lot of that in the climate risk domain. And today we're starting one of the first of three sessions featuring OS Climate. We on the presenters list today, we have Truman Siemens, the CEO and founder of OS Climate. We have Leila Javadova from Allianz, myself, Vincent Caldera, and Abubakar Shaibu. Although there is an apology from Truman, who has actually hurt himself and is recovering in his hospital bed. So I'm going to take his slot today. So welcome to this presentation. It's a long title because OS Climate is actually working in quite a lot of fields, but ultimately we're going to talk to you today about our climate relevant projects around data and analytics. So in brief, OS Climate stands for Open Source Climate, and we are a Linux Foundation company, and Linux has given us probably some of the greatest and diversified collaborative open source projects in the world. And here what we're doing in OS Climate is we're applying that mature open source approach, which has been key to developing, for example, the COVID vaccine in its rapid deployment, and also responsible for many other initiatives around the globe. So OS Climate, we're a non-profit, member-driven organization, and fundamentally we're addressing the challenge of data gaps and tooling which are required to give us the insights into aligning and transferring investments and loans towards a more cleaner, sustainable society, and also towards a more resilient society around exposed to the impact of changing climate conditions. So we've got a broad membership base. Some of our members are all up on screen here, but we can include BNP Paribas, Goldman Sachs, Allianz, Amazon, BNY Mellon, Capgemini, and our community extends to academia, research institutions, and many of the relevant bodies in this climate field. So we're not going to cover all of this slide today, but I just want you to look at the blue bar. Ultimately, what is open source? Well, open source is a methodology and approach. Right. Okay. Tell me if is that a little bit better? Okay. How's that, Myra? Yeah. Great. Apologies, everyone. So open source, it's really a methodology and approach where data tools and platforms are free and open access. They're characterized by transparency and collaboration. And what we're doing there is we're producing shared and public benefits. And these can either be shared entirely or shared for the purpose of pre-competitive collaboration to drive better commerce layers sitting above this open code and data set. So in principle, OS Climate, on the left-hand side, you see our collaboration community. On the middle, you're seeing our data project, which is going to be presented today by Vincent. And then on the right-hand side, we have broken down the analytical challenge into three main projects. The first is physical risk and resilience, looking at the measuring the exposure to changing climate conditions and what that means to lending and investing around the world. The carbon alignment project, which Leila's going to present today, and then tomorrow's session with OS Climate in the afternoon will feature the transition scenario analysis in a deep dive. So in principle, why are we doing this? Well, actually, the space is really interesting because we started as a member-driven community from the sort of financial institutions perspective. So on the right-hand side, you see the benefits of a sort of private partnership and to collaborate in this field because a lot of these challenges we're talking about are shared. And then on the left-hand side, clearly a lot of the problems we're talking about are also shared by academia, governments, and NGOs. And then there's this beautiful sweet spot in the middle where we all share this.
or the SBTI target setting framework for financial institutions. And target setting is set on multiple levels. So on sub-portfolio level, on sector level, for engagement activities, and for financing transition activities. And that means that if you want to effectively decarbonize, it's not just about pure asset reallocation or divestment, but it's really about understanding how sectors decarbonize over time. And it's really understanding how issuers or how ambitious issuers are in their efforts to decarbonize. And in this sense, forward-looking climate models, and I'm not just talking about implied temperature rise model, but also about fiscal risk assessments, transition risk assessment, any type of forward-looking models that helps you for different use cases to really be able to actively steer your portfolio towards decarbonization. So that means really understand who are the 1.5 degree aligned companies in my portfolio, where should I phase out slowly, out of which sector, out of which issuer. It's very useful for engagement purposes and for disclosure purposes and so on. It really depends what your use case would be. So what are we doing at the end of the day? If we go to the next slide, please. And the next slide, please. Yes. So what we have done so far is we have built a purely open source model, implied temperature rise model, based on the recommendations as set out by TCFD convened portfolio alignment workstream, as well as GFANZ's portfolio alignment workstream, that really is comprised of backward and forward-looking data that assesses companies in terms of their decarbonization efforts, or assesses sectors in terms of their decarbonization efforts. Now, I like to call it a sector alignment tool and not a portfolio alignment tool, what, for example, TCFD or GFANZ likes to call it, because there's not really credible methodologies out there to cover the full asset class spectrum. You cannot cover sovereign bond issuers, covered bonds, or mortgages, and so on. But we can cover listed corporates and public equity. So for that reason, what we have done so far, we have built a tool that is fully transparent, which I like. We don't like black box models. We would like to understand what the tool does. Fully accessible, and with various scenarios integrated, such as the TPI benchmarks, One Earth climate model scenario, 1.5 degree aligned scenarios. And it is also comprises various sectors such as utilities, oil and gas, steel, cement, and so on. And what the tool does, it basically compares various backward and forward-looking data, as I say, and assigns a temperature rating to companies, such as company A is 1.5 degrees aligned, company B is 2.7 degrees aligned, and so on. So if you go to the next slide, please, you will see, I will just quickly explain to you the calculation model. I'm not going to go too much into detail because it can get a little complex. But just for you, as you see, is what we do is we take scope 1 and 2 emissions of companies, as well as their 5-year historic data. We take their physical production outputs, so if it's a steel company, the tons of steel produced, and 5-year historic data. We project it until 2050. That's the backward-looking part. The forward-looking part are the climate targets. So absolute targets, intensity targets, doesn't matter. We take that information and we assume if the company would actually achieve those climate targets, what would the intensity be of that company? And then we do another projection until 2050. So if we go to the next slide, please. So what happens is, once we have our projections based on physical intensities, based on climate targets of companies, we compare that information to a specific scenario. So, for example, we use the One Earth climate model. We like it very much because it's a very granular climate scenario for various sectors. And we basically compare our data to that scenario, and we assign a temperature rating. That's basically the whole, let's say, concept of the temperature alignment. Let me tell you that it's a snapshot of your portfolio. It's a snapshot of a certain issuer. Once you do an assessment as such for a certain sector, for a certain portfolio, you need to understand that you need to take into consideration various, let's say, various impact from outside, political developments, and so on, in order to be able to correctly interpret the results. But it's quite a useful tool to be able to really understand really climate ambition of various companies, and to understand where it really makes sense to engage, where it really makes sense to phase out. And as I say, it's also a great tool for regulatory compliance, especially in EU, with a evolving regulatory landscape around disclosure, as well as for engagement purposes and disclosure purposes. If you go to the next slide, please. So what you see here, we have built a user interface that is quite dynamic and where you can really play around. So you can really cross-compare various sectors, various scenarios. You can cross-compare your results with including Scope 3 emission data and excluding Scope 3 emission data. So you can really understand what is the impact of Scope 3, as it's very material for certain sectors. And you can really use various aggregation models, weighted average, enterprise value weighted results, and so on. And what I also like very much is that our scenarios are also region specific. So it will make a difference if you compare a utility company to a climate scenario in Europe versus global climate scenario. They will probably get a lower value, or let's say a worse result for a European benchmark, which is stricter than for a global benchmark. So last but not least, if we go to the next slide, what we do is really try to give you transparency and allow you to decide what your use case is for that tool. It's not one bulletproof, let's say, solution to all your problems or to all the problems that financial institutions have when it comes to decarbonizations, but it's one of the puzzles. And it's really about how you combine these different forward-looking models to effectively decarbonize over time. And yes, so fully transparent, what I very much like, and you're welcome to play around with it and to try it out. Because one more thing, the tool is not limited in terms of its capacity, how much data it can process. So you can use open source data if you have collected some data, because OS Climate does collect some data, or you can use your license providers. That's why we call it a partial independence from commercial providers, because if you have, let's say, Scope 1 to 3 emission data or physical production data from a license provider, all you need to do is feed it into the tool and really see the results. That would be it in a summary.
Thank you, Leyla, and we will indeed take questions at the end. So that's one of the 3 projects. So let's now shift to the right-hand side of that segment there, to physical risk and resilience. So let's begin by framing the use cases. So what are we trying to do in terms of physical risk and resilience? So obviously, financial companies such as lenders and investors, we're all trying to disclose more information about the risk that we're facing to the changing climate conditions. We need to be able to measure the risk in our portfolios and perform scenario analysis on those, because there's many different carbon pathways that we're going to head to in the future. So there's scenario analysis and stress testing. We also need better tools for origination of loans and investments. So the decision to lend, for example, to a hotel chain that's on the coast that might be partially underwater in 30 years' time is a decision that needs to be relevant today. And operational risk, of course, even financial institutions, just as corporates, we all face the risk of our activities and sites shutting down due to extreme weather conditions. But the The golden piece of our project, of course, is that once you can measure the risk, you can define resilience and adaptation finance, and that's the level that we really want to get this to. So you've probably heard a lot about transition finance, but we don't hear so much about resilience finance. So how do we help the world make itself more resilient to the physical changes in climate, such as more wildfires, droughts, heat waves, flooding, wind conditions. So the starting point of all of these use cases is risk measurement. You cannot manage what you cannot measure. And the great thing about this project, as you're going to see a little bit later as well, is the underlying theme is that we are all trying to do the same things. It's not just a case of financial institutions that need to measure and understand this risk. But if you're a farmer, if you're a power producer, if you're a country, region, national development organization, you need to understand and manage these risks. Sure. Thank you. Just wave if I need to raise volume. So how do you do that then in an open source project? Well, the principle is to create a plug and play environment. And what we do is we break down the physical risk measurement into these core building blocks. So I just draw your attention to the colored squares on this slide. So we start with a hazard model. So the hazard model describes the probability of a flood occurring, a drought, a wildfire. And then we need tools and analytics in the open source domain that connect that to assets. These are assets that are geolocated around the world and they have certain properties about them. But that's not good enough. That tells us whether these assets are exposed or companies are exposed. But we then need vulnerability models which explain how vulnerable these assets are. For example, a power plant is going to be far more vulnerable to high air temperatures and drought conditions than a warehouse or an IT software services firm. And when you combine all those building blocks together, you can produce risk distributions. And from those risk distributions, you can make decisions around lending and investing and portfolio risk, and you can feed them into your own proprietary credit models. So the great thing about these building blocks is that if you think about it, even up to sort of 3/4 of that blue box, this could all be done in a pre-competitive space. It's only really the final stage of integrating that into a lending or investing organization that might be proprietary. For example, a bank like BNP Paribas may have no interest in developing its own drought model or a chronic heat model. We would much rather collaborate to deliver this. What does the ecosystem look like? So obviously we're presenting here the Linux Foundation, and that means that we're looking at end-to-end. So we're not just talking about analytics, we're working end-to-end, which is bringing the data as well to the tooling and the coding architecture and the plug and play. So what you see on that left-hand side then is this data mesh architecture, which is able to feed those building blocks. And then on the right, there's some images describing sort of some very very sort of basic, origination decision-based spider charts. And on the bottom right there, you're seeing some evolution of a chronic heat model. And by the way, this is all open on a website. Anybody can access this. And what we're also doing, if you look at our user interface, you also see we're exposing the mathematics. So we're really trying to create an open common language to how we interpret and understand climate models. So let's recap then to what are we representing here today from OS Climate? Well, we're really big advocates of open collaboration. And why are we doing this? Because it helps us build capacity. It helps us bring knowledge into our own organizations. Like when financial institutions came into this problem, we weren't experts in climate science. We need to integrate that knowledge. What better way to do that than to create a community of collaboration, bridging research institutions, NGOs, academia. For example, we've just onboarded a wind model from Imperial College London, and I think we were just joined earlier by one of our Imperial colleagues. As I've said, when I drew up those building blocks, what the work we're talking about here, there's a lot of common tasks. So if we can collaborate, we can eliminate those common tasks together and provide that access to world-class research. Now, fundamentally, on the bottom left-hand side, here's a really important point. The measurement that we're talking about is extremely complicated, and it's very black box. If you, particularly if you look at much of the commercial space today, there's one answer that tells you a yes or a no. The answer is 10 or 20, 50. But that's not good enough for a long term. vision. What we really need to understand is the uncertainties behind these numbers. So by encouraging people to collaborate in a building block plug and play environment, we can take more control over those models, and we're able to plug in open models and plug in commercial models on top of that. So this is not about competing in the commercial space. This is about working with commercial providers that can plug in their proprietary models on top of our platform, but are now allowing us to take more control. For example, if you take a damage function that tells you the level of damage that could occur on a property, take from an insurance model when there's a flood. A bank may need to demonstrate to its regulator what's the uncertainty behind that damage function. It might actually want to plug in a different damage function, or it might want to take a flood model from a different flood provider. So that's what we're really doing in OS Climate, creating that plug and play architecture. And then the thing that I like the most actually is this right-hand side of this project, where as I've mentioned, a significant amount of this modeling and code that we're working on is also very relevant to public interest cases for adaptation and resilience. For example, if we're working on drought models, these drought models that are all open source and available around the world, can be used to help and inspire data scientists in Nigeria, for example, to work on agriculture resilience projects. And that brings me on to my good friend Abubakar Shaibi, who's going to explain one of those great examples of how someone is building a philanthropic layer on top of OS Climate through the Climate Risk Research Challenge.
This one? Yeah, close. It works? Yeah, this one works. Hello, good afternoon, everyone. Yeah. My name is Abubakar Shaibu, and I'm the founder and CEO at Green Energy Mission Africa, and also the lead for Climate Research Challenge 2023, which is a project under Sustainable Africa Initiative with two member organizations in Africa, Sustainable Solution for Green Growth and Green Energy Mission Africa. So let me begin by telling a short story. Last year, I and Aziz Abubakar, who is not happened to be here, we met Truman and Brandon, of course. So we went into the event at the Global Innovation Hub, and we've seen the work that OS Climate is doing, and we feel like, this is something we could do in our country. This is part of the challenges we are working around. So got so kind, we did Climate Research Challenge 2023, and I will be taking us through the Climate Research 2023. So actually, Climate Research Challenge 2023, leveraging on OS Climate, we launched the challenge to end hunger crisis and improve food security in Africa, and also looking at the transition that is going on in Nigeria, set up a target for transition to net zero. But also the transition has consequences, and one of the consequences is food security. So, and to go back, the biggest sector to go back in Nigeria is the agricultural sector, and the agricultural sector faces numerous challenges that are directly from the climate crisis. So we said, okay, let's try this. Let's try to do a work around agricultural sector. So we work with 10 universities in Nigeria, and through OS Climate, leveraging on their resources, we are able to develop a challenge where we work with 10 universities, and we build capacity of 300 students in Nigeria, and the students works within 30 communities in Nigeria in relation to drought and droughts, and also 300 students, 30 teams, and they model 30 crops in Nigeria across the socio-political zone in Nigeria. So what OS Climate members did and support with is training the students on how to use their data and tools that are available. For instance, the climate data, the rainfall data, and also the tools needed to actually model and to predict what is going to happen in the next in this type of crop. For instance, this community is doing a rice farming. So how this rice is affected by climate change and how it is in relation to drought and droughts. So we did 30 crops, which are majorly consumed by Nigerians. And with that, OS Climate members have supported with tools and data, and also build the capacity of young Africans. But one of the most important thing here is this, at the heart of this project is that this time around differently, let African take charge of their improved and developed data. So this is one of the most important thing, and also we can proudly say for the first time something like this happening in Africa, and thanks to the OS Climate Members, Linux Foundation, and Climate Research Foundation. So going further, we actually started with capacity building. We provided support to passionate, smart university students and professors and leading agricultural universities desire to drive positive change for their communities in Africa. So with that, we were able to secure $60,000 worth and 50,000 in cloud credits by Amazon through AWS, and also a challenge that's a cash prize of $10,000, which is provided by Climate Research Foundation. So right now, I can tell you, we already finished the project. The student has submitted their work, and we're working hard to hard. At the end, what we are trying to do is to develop agricultural outlook for Nigeria, because these 30 crops are mostly consumed in Nigeria. So if to say that we Africans and of course young people at universities level are able to do such kind of work, this data is going to be important for the government of Nigeria, for the banks, for the industries and development partners to see how this is going to look like in 10, 20 years to come. So this is important, and also at the heart of this capacity of young people has been built in the process. And also $5,000 was $10,000 in cash was prized to the student winning. The first team, second team, and third team take it. And also $50,000 in cloud credits for the winning university. So it's been an amazing to work with members of OS Climate, and we are going to Kenya next year to do the same thing. And what we are able to do, we're going to replicate it to other African countries. So at the end of the day, we'll be able to have data of climate risks, climate data in relation to drought and floods in Africa. So I think this is going a long way for investors, for banks, for industries, and of course governments to have real data that they can use to inform and make decisions when it comes to policy alignment in agriculture and food security. Thank you.
Thank you, Abubakar. And I think it's important to add there that one of the things we believe in is that, as has been said, the work in Nigeria, modeling and in this modular way it's going to make it much more easier to then translate those models to other countries of the world and bring all that back into OS Climate. So rather than a development project, for example, sitting on somebody's laptop for 3 years and waiting for a budget to run out, this presents some longevity to this this development challenge. Okay, so we're now going to move to the final part of our presentation, and so you've heard a lot about analytics so far today, but we all know that behind those analytics sits a huge data challenge, a challenge of getting data from multiple data sources around the world. There's never going to be one single golden data source that solves all of our problems. And so what you're going to hear about today from Vincent is the work that OS Climate members and Red Hat have been doing to address this challenge. So over to you, Vincent.
Thank you, Matt. I think I'm going to save myself some neck twisting and move on the side. So you heard a lot about various exciting use cases. The one thing they have in common is all of them need data and they need technology to actually happen. So Red Hat and Amazon Web Services are the two technical collaborators who have been supporting OS Climate, mostly on digital infrastructure. Now, if you look at the key problem we're trying to address, it's really the challenge of accessing data and also working on the transparency of integration between the data and all the exciting models we've seen. Now think about it from the perspective of someone starting a project like physical risk resilience or portfolio management. We are looking at potentially thousands of different data sources from different public and private organizations that you may have to integrate. Now, this data is not necessarily well documented. It's not as well coming straight out of the box with challenges like overlapping, ontology issues. So essentially, it's a very, very big problem that a lot of climate data scientists spend too much time dealing with. So when we started looking at how to address this, what we felt is if we try to somehow create a master database of data, we're going to fall into this trap and we're not going to be the first one, of really spending most of our energy and time just trying to build interoperability between data. And we thought there's probably a better way, a better technology to do this. Next slide. So in terms of fundamental change in architecture mindset, what we did is, instead of actually trying to centralize the data and building a master data warehouse with all the data that all the streams would need, we chose a fundamentally different approach, which we call a data mesh. But essentially, the term that you may prefer to use is the term of data federation. Instead of actually trying to centralize the data, we actually try to leave the data where it is and build reusable recipe for the data to interoperate. So our goal is to make data easily shareable, but we also want the recipes to access the data to be shareable. We want them to be transparent. This type of architecture approach is the way to do so. Yeah, next slide. So what we've built essentially is 3 types of feature to solve 3 different fundamental problems with data. The first problem is data accessibility. In order to help with data accessibility, what we decided to do is to build data infrastructure as a platform. So what it is as an organization, we provide you with a reusable recipe with open source technology project where you can basically build your own data sharing node. So whatever data you want to share, there is like a reusable blueprint that you can build with your own organization to integrate with this federated group of data provider. The second problem I will try to address is about data comparability. So how do you make sure that there are people who understand the source of the data and document what this data means? We've got a concept here which we call data as a product. Right? So inside OS Climate, we've got data product owner, people who understand the source and who are able to actually understand which is the appropriate source, which is the right kind of data dictionary to be built, what's the way to actually transform the data to be interoperable. So this is basically the type of work they do. And of course, they use this infrastructure and platform to do this work day to day. Last but not least, there is a fundamental problem as well about transparency. It's not a problem that's specific to climate, by the way. Any one of you who's been in the academic community, how many times have you had this issue? You have a very nice study that's published, fantastic results, and then you try to reproduce it, and you've got vastly different results when you actually try to run the same scenario. The problem of transparency is actually a problem of repeatability. From the data source all the way to data transformation, all the way feeding into multiple models, how are you able to repeat independently what a third party has done and validate the result? In order to achieve this, we build capabilities around federated governance. So the idea here is we use a principle called data as code, which means that every bit of data integration we do is actually checked into a repository just like open source software. So anybody can independently reproduce and validate the findings with data. Yeah. Quickly on data governance. We found fantastic application of data governance this year in the space of reporting. Because as we are now, I mean, personally, and I don't think anyone believes that there's going to be some global standard for reporting of GHG emissions. We've seen too many initiatives across the globe to come up with their own standard, depending on specific country or specific industry requirements. So instead of trying to convince everyone to follow the same model, another approach that we found to be useful is the concept of federating different reporting entities and then managing the rights to data. So you've seen earlier, in our architecture, what we make sure is the data doesn't have to move to be accessible. So when you think about this in terms of different reporting entities, with this type of approach, we can actually allow each other to have access to their own data. And that actually helps us to build mechanism for interoperability and inter-reporting. So that's fantastic because it means we can work with both public organizations and potentially private or semi-private data as well, given the fact that the owning organization can appoint data steward that manage the policy of access to their data. Right? So The technology has this capability that protects their data, and they can define access and sharing policy, which are effectively governed by the technology. Next slide. So this architecture and the platform, we've been working on it for the past couple of years. But in the past 12 months or so, the focus has been trying to identify use cases around standardization. And one of these use cases is around the PCAF, the Carbon Accounting Financials, and some of the implementation standard around finance emissions reporting. We focus specifically on one asset class that is new to those standards, which is the sovereign emissions, the sovereign bonds. So if you are familiar with PCAF, it's a very interesting initiative because it has the benefit of providing one single framework for various financial institutions to report on finance emission. So that's a great advantage, to be able to look at the same 100-page document and trying to follow the same methodology. But all of you know that when we look at the same 100-page document, we may not implement exactly the same way or the methodology in the same manner. Why? Because you need to make certain choice on the source of data. You need to make certain choice on the definition. You need to make certain implementation choices as well. So OS Climate tackles everything on top of the standard. We took the document, and in particular with one major contributor, which is Allianz, we basically set ourselves to implement the standards for sovereign bond reporting. Next slide. So what we've done, and I'm actually using some a cut of the meaningful data sources for the implementation of the standard. We basically integrated a number of different data sources, mostly from UNFCCC as well as OECD, and then some of the World Bank reference data with regards to some of the standard macroeconomics that you need to have for this methodology to be effective. And so what we built essentially is all the data integration and then all the implementation of formula to structure the reporting of the sovereign bond emissions. Next slide. And so now we basically have an end-to-end, it's almost like a production pipeline, right? We basically leverage our partner Amazon, in particular their initiative, which is ASDI, to provide some of this data in an open manner to data consumer. And then we have implemented some code. You can look at the bottom, it's actually available on our GitHub repository, that takes the entire end-to-end process of sourcing the data, performing the transformation, and all the way to visualization and business intelligence tool, which are used for data discovery and for analytics. The important, I know it's a complex picture, but the important thing to really remember about it is every single part of this process that you see here and the supporting technology is very much open source. You don't have any license for software, any license for the data to actually implement it, which means that whether you are a student, a research organization, or a financial institution, you have like a starting point for the recipe just to be able to get your implementation meaningfully started in the fastest time possible. All right, so that's it for my part of the session, and handing over back to Matt.
Wonderful. Thank you, Vincent. And perhaps I'll just add on to that. What I personally like as well about this approach is that this is agnostic to data type. So this mesh concept is just as relevant to biodiversity and nature data as it is to climate, and relevant to sharing data between supply chain up and downstream. And translating taxonomies for financial reporting from one side of the world to another, and many other use cases. So that concludes our presentation. What we would now like to do for the remaining time is open up to the audience for as much of an interactive debate or questions as possible, and we'll be here to answer and feedback or drill into something. Right, I'm going to hand you the microphone. Yep.
Thank you. My name is Chinedu Onizu. I'm from Nigeria. I have a question for you and for the man. my question on the model you shared, I think it's temperature based. Have you tried to use maybe CO2 as a variable, CO2 emission as a variable in your model to determine
We have-
how the crops
Yes.
will respond to CO2 changes in a region instead of temperature?
The CO2 changes in the region, you mean like an outside-in perspective?
Yeah, so I'm concerned that regions have some regions might not see any significant change in temperature over different farming seasons.
Ah, okay. So what we do is we have, is it working? I'm not sure. Yeah. So the only region specific view we have is to use region specific scenarios that is out there. But that's also unfortunately a little bit limited. So we have specific decarbonization scenario for North America, for Europe, for emerging markets that we can use to somehow assess the impact. But that would probably be the only region specific perspectives that we can build in, to be honest.
Okay.
Maybe Arad and perhaps Abu Bakr wants to come back on this. So I think I also read something else into your question. Yeah, there's obviously two types of physical climate change, and these are typically classified as acute risk, which is the extreme events that can occur, like a drastic drought over one growing season, or over one power plant in California, whatever it may be, extreme air temperatures. So these are chronic, acute events. Typically modeled by insurance in industry. And then there's the chronic, which is the long-term changes in climate conditions. So what are the average levels going to look like over the next 10, 20, 30 years? So we're interested in both. And typically the starting point for those are these integrated assessment models that come from the IPCC and the derivatives of those. So they're not just temperature models, right? They start with different greenhouse gas pathways under different macroeconomic scenarios. And then if you imagine you take the globe and if you put loads of tiny squares around the world and build that up to the stratosphere, then they're mathematically solved for all conditions like precipitation, rainfall, wind, everything. So these are all encompassing. Now these models are typically global, but then there's a lot of people involved in downscaling them, so making them relevant to particular specific regions. So if you've got a particular altitude or concrete base, there's going to be different conditions localized. So ultimately, yes, all these things need to be taken into account. But what we're trying to do is bring some open understanding to the problem and helping people not just build up a picture of that chronic, season ahead risk, acute season ahead risk, but what's it going to look like in 10, 20, 30 years? Because this could be absolutely catastrophic. If your average temperatures that you're going to see are going to be 2, 3, 4, 5 degrees higher, then all your fluctuation and acute volatility is going to be around that different starting baseline. And that's the real problem. And what I think is going to happen is that our ability to measure this long-term chronic risk, it's only a matter of time before that becomes priced in to current value of assets. So we've probably got 5 years maybe in total before we see dramatic asset reduction. So we obviously are here to help. We don't want to just stop lending to the world. What we want to do is measure that risk and then use that to define these adaptation finance products. So how do you support people in translating? So what should you crop? Do you want to start growing more resilient species of maize, for example? And these are all these different resilience adaptation measures that can be put in place. But what we're trying to do is empower those locations of the world to make their own decisions and inferences.
Okay, thanks. I have a question on data. Can you speak to what efforts some global leaders have put into standardizing carbon reporting, carbon emission reporting? In my past life, I used to work for an IOC, an international oil company in Nigeria. And coming from the Niger Delta part of the country, I see a lot of active gas flaring activities and operations. Unfortunately, the companies try to report based on their understanding on standards. I'm happy to see your efforts, as trying to standardize that process. So can you speak to a little to what leaders, the effort global leaders are making to make sure it is standardized? And then secondly, I think there needs to be more visibility to these operations across board. And I think also that the emphasis shouldn't be much on penalties. We should find ways to incentivize the right behaviors, so that companies that depend on emissions in their operations will invest a lot, in green projects so that they can net out the impact of the operations in the environment. Thank you.
All right, so that's a lot of questions in one, but let me share maybe my perspective, right? So one thing is I have seen a lot of efforts on making reporting mandatory, but too little effort in building an actual interoperability and understanding of the actual figures. What's happened, as a result is in the case of OS Climate, I know we are engaged in a couple of almost competing standard implementation that are actually country specific. And while we are helping with everything related to data management and infrastructure, the shame in that is, there's not really a very active collaboration in ensuring that there's I would say similar methodologies and documentation around how the reporting has to be done and how the data has to be managed. So from my perspective, I mean, especially coming from the mindset of a technology company that is very focused on open source and really believe that the best innovation out there is coming from collaboration and people aligning with the same individual and same methodology. It's very painful for me to see how much resource we spend globally to deal with the same problem, but with obviously all the silo of organization all trying to impose their own standard. Not that I can change it, I'm just a technology person. So I can find a lot of smart ways to use the tech, but politically, I can't really convince people to help. Just to mention before I leave it to you is because I am actually based in Singapore, and Singapore has a very interesting initiative that's called Greenprint. They're actually building a registry for carbon and carbon reporting. And I would say it's probably best in class in terms of bringing the industry and the collaboration and opening, to small innovative companies to actually build the infrastructure and really in a way that is not trying to push the standards down to the industry, but rather very consultative. So I think the methodology is very interesting to look at if you are looking at a way that we could actually build this type of infrastructure. Of course, again, the challenge here is Singapore is actually very small in terms of global footprint. Yeah, but just something to look at in terms of maybe best practice in terms of opening standards and implementation strategies.
Maybe just to add to that, because past couple of years, all I've been dealing with is ESG data. So let's get it straight. ESG data, and irrespective if it's emission data or any type of other data, it's uncertain. And if we wait for the perfect data, we're all going to die. So we have to make the best use of what is available currently. And unfortunately, especially when it comes to emission data, yes, the GHG protocol is taken as a basis, but then providers or companies start putting some kind of estimations on top of it or customizations on top of it, and then data becomes incomparable. That is something we have to accept. I challenge you to, if you have access to various data providers, take one company that reports the data, compare the results, and I can guarantee that 75% there will be deviations. And that's normal, I guess. That's something we have to accept. What is definitely happening, and that's a great development, especially in Europe, that we have the corporate sustainability reporting directive coming into effect next year. We have the sustainable finance disclosure regulation, and all of that pushes companies and financial institutions to publicly report their emission data and various KPIs. That, of course, makes it a little bit more comparable. I also know that Europe, for example, also works on a single data access to make really data accessible to everyone, which is fair. Because if we want to push companies to set climate targets, if we want companies to, and smaller financial institutions and pension funds to decarbonize, we need to make sure that we give them some kind of tools to be able to do that. That's also what OS Climate is working on, is really giving you the fair access to various tools and data to help you to decarbonize or set climate targets. So I guess things are developing in Europe. Things are definitely developing in Singapore. I know that as well. And I hope that just kind of has a spillover effect also to other regions.
Thanks. Hello, Henry Franks, Climate Policy Radar. Thank you for really fascinating talks. I have a question about the data mesh aspect of things. So we are a data aggregator for climate policy data, typically extracted from the documents themselves. I'm really intrigued, and I want to get a sense from your talk as to the practical costs and complexities of federating into the data mesh and adopting that architecture, especially as a small resource-constrained startup. It feels like potentially it's quite a large imposition.
All right, so yeah, there's two aspects to it, right? So first, one of the costs that you have, which typically is the building your own infrastructure. You will see that actually some OS Climate members are actually startup company. And I mean, I talked about Singapore earlier on. We actually have a new member which joined us recently called UREG. UREG is actually working right now with our team to build open source equivalents to ESG standards. Now, as a company, their expertise is actually in terms of reporting and disclosure. They do not have a lot of people who understand data infrastructure, even less so people who can deal with unstructured data processing, who have expertise on artificial intelligence. So fundamentally, the partnership for UREG, I believe, has been quite efficient because it provides both technical capability and expertise on certain domains like artificial intelligence that a small startup would really have difficulty to get, right, or to finance on their own. So it's both access to resource, access to software. Obviously, we also have received a lot of support from Amazon in terms of support on infrastructure, without which I couldn't, play during my weekend to use the latest advances of AI to process data. So all this is necessary, but it's actually a great story in my view to solve exactly the problem you mentioned. We really look forward to have more members bringing, I would say, business level innovation into this community. And everything that's technology that I've presented, the purpose of this is to make it as widely accessible as we can, to be honest, right? So we have not even turned away any prospective member who come and wants to build a new stream of contribution within OS Climate. We're actually encouraging this. Yeah, so I think Matt mentioned earlier biodiversity is an example of a stream that we would very much like to see in the near future coming and collaborating with us.
Great, thank you.
Thank you for the discussion. It's very insightful. And if it's to the area of what we do as a company, so we're another company, 4 years in the business doing physical climate risk. So two questions. How good, or maybe it's an indirect question. How do you deal with flood risk? Let's put this, a rainfall flood risk. This is not open data. This needs to be modeled. And if you're asking for sharing this data to the public, you as a startup giving your IP. So, and on top of that, you are in Asia, where is no past data. So.
Okay, this is a really great question, and it gives me the chance to probably clarify what I tried to rattle through in a very short matter of time. So, indeed, as I said, we are not in the business of trying to compete. What pre-competitive collaboration is all about is about commercial data providers and institutions, research banks, all working together to create those common building blocks to allow us to plug in the best available open models, and when we need them, to plug in those commercial models. So flood is a brilliant example where, as you've said, the hydrological modeling of rainfall is extremely complicated, and in especially the downscaling of it. We're not going to get into that space, right? So what we do is we create that open source code that provides the building blocks. So we can, and any institution or anyone can take our ecosystem of code, deploy it very quickly, and then plug in on top of that through a commercial API, a more advanced, like 1 square meter resolution flood model. And as I said, the key thing is that we can then play around with those damage functions as well that come on top of that. So it's one thing to know the probability distribution of a flood depth. Second is to actually then know what is the potential damage, and how many samples are actually done when that's sort of simulated. Some companies only take 10 samples of a damage function that shows the probability, because we don't know exactly the strength of a roof during a hurricane, right? We don't know, right? These are called epistemic uncertainties, right? And so in principle, we might want to make more samples through in the banking industry just to be sure. And then another good example of collaboration on that, it's one thing to then understand the potential level of damage that could occur in year 1, in year 10, in year 20, in year 30. The other challenge, which is great for collaboration, is how do you translate that insurance damage function number into valuation of the asset or property? And that's also a great topic. So hopefully that answers your question. But if you imagine those 4 building blocks that I showed you, you could overlay exactly the same building blocks from a commercial partner on top of them.
Absolutely, because from our observation, many companies will not give you the hazard data. They'll give you an average damage curve, they'll give you whatever possible, but not give you the unit of how many meters of flood is there. So you can't make the translation if you don't have this as a start.
Yeah, so one of our great partners is like Jupiter Intelligence, commercial hazard data provider. They've provided an open data set at 30 kilometers resolution, right? So
30 meters.
30 kilometers, right? Okay, so this means that you can't use that to make a decision on flood. You can't use it to necessarily make an uncertainty decision. But what the idea of them doing as a commercial collaborator is that they get their data out there, they help people get started, make some global calibrations, and then plug in the commercial model on top. So that's a good example. The other approach that data providers can have with us is they could, for example, a flood provider like JBA or Fathom, some of the experts in the world in that sort of modeling, they might make a decision to release highly granular data set, but just for a small region of the world, to show people then that can download that end-to-end source code to show how it's computed, and then to purchase for the rest of the world, you go and buy the commercial activity.
Can I have one more question?
Sure.
I have a finance background, and I run the climate tech company. So I come from quant kind of trading, etc. If you talk to the companies, you give them the climate value at risk, whatever the number, or banks, right? So the stress testing and etc. But they say, I can build a buffer around that. And they will only take it seriously when the insurance market starts moving. Once that insurance will kick in, of course, the valuation will get adjusted, but we don't see it yet in Asia. We see it a bit in US and Australia. You had a 5-year projection. I have a 1-year projection for adjustments, a bit more optimistic. But what is your opinion? What is going to move them?
My opinion is to leave your card afterwards, and we should have a long discussion about this topic. Look, there's lots of different debates. So if you take the topic of capitalizing a bank, you typically look at a shorter term horizon, like 1 to 3 year horizon. So you're not necessarily going to intuitively capture these long-term changes. An insurance premium is looking at 12 months ahead, right? So that's not going to necessarily capture it. We are addressing what we think is one of the fundamental gaps, which is, like I said, the long-term changes in climate conditions and how that could actually translate into near-term valuation. Like I said, it's only a matter of time before we realize, which real estate around the world is going to be underwater, right? Which farmland is going to be unfarmable, and that's all going to translate into today's value. So it's not a problem for 30 years' time at all. So what we've really tried to present to you today is just our mindset and way of thinking, this building block ecosystem collaboration concept. And we're here to solve these problems amongst our members. So let's talk again. But perhaps we've got one last question, and I would ask you if you've attended, because we wanted this to be an open session today, so we haven't taken your names, but please leave your cards, and we can then reach out and connect with you afterwards. So one last question, perhaps.
So thank you very much for all your presentations. I only dropped in late, so maybe this is a very stupid question, but so you're linking data sets with methodologies on risk assessment, but as well you alluded to, there's between ESG data providers there are always differences. Same thing with, for instance, the impact valuations. So how do you decide which ones to take on board and which ones not? Because that's what I see happening in well, for instance, stress testing, is that there's all kinds of like choices made which damage function to take in and which one not. So some are more conservative, other lead to higher impacts. So how do you go about with that discussion?
Okay, that's also another one that requires a longer than 30-second answer. This is exactly the point, right? No model is perfect, and there's a huge amount of uncertainty out there. So how do we go about it? Our approach in OS Climate amongst the community is to expose all of those open models so we can compare them. So for example, if you go onto our website, you'll find all the different SIMs that come from the CIMIP 6 sets, right? So you can compare like one chronic heat model with another. And if we can put them all up against, in front of somebody and try to understand the uncertainty behind it, we at least have got a chance of making an educated decision. This is about making a risk-based decision, right, on the topic. So yeah, no model is perfect, but also by opening up that black box as much as possible, which is the philosophy we presented today, you have more chance of people understanding the model and the data that you've got. So that's the way of thinking that we deploy.
Maybe just one comment on implied temperature rise model. That is the magic of open source, because we make all our assumptions public, so, and our methodology. So you can actually trace within the model what is driving the exact temperature rating. Is it the physical output? Is it are these the targets or the emission data and so on? You can really track it down. And that's why it's very easy. Let's say it's easier for you also to judge for your particular use case whether you can resonate with that result or not. And what the tool also, for example, what I like is it can calculate temperature rating based on your physical intensity at a minimum without a climate target, but not vice versa. So we're not trying to say that just because you have a target, you get a wonderful score. That's not how it works. But as I say, that's the magic of it, making it all publicly available and really choosing for yourself what data makes sense or not, and what's basically driving the results.
Great. Well, thanks so much. Please hang around afterwards. We'll be here for a few more minutes. And I'd like to thank Linux Foundation, IAI for hosting us today, and all of our panelists. So thank you.